Coming up on This Week in Radio Tech, Chris Tarr is here, and Doug Vernier is our guest. I don't know if you've met Doug or not. I really hadn't met Doug until this show. Let's spend an hour together and find out about the amazing world of computer software-generated maps for RF propagation and all the things that you can do with those. Coming up next on TWiRT. This Week in Radio Tech is brought to you by Broadcasters General Store with outstanding service, savings, and support. Online at bgs.cc. By Broadcast Bionics with the Bionics Studio, including talk show control, social media, and visual radio. Broadcast Bionics brings exceptional audience engagement to radio and TV. By Angry Audio. Audio problems disappear when you get angry at angryaudio.com. By Nautel, worry-free transmission you can count on with outstanding control, reliability, efficiencies, and Nautel's unmatched 24/7 customer support. Online at nautel.com. And by Max Connect Wireless, prioritized high-speed internet service designed for transmitter sites and remote broadcasts. Hey, welcome into This Week in Radio Tech, the show where we talk about everything from the microphone to that light bulb at the top of the tower. I'm Kirk Harnack, your host in the Nashville studios of This Week in Radio Tech, here in the Nashville office of the Telos Alliance. That's what I should say. Telos Alliance Studio. See, it says that right back there, Telos Alliance Studio. Thanks a lot to Telos Alliance for giving me a little bit of time to do the show and bring you lots of good stuff. So it's a beautiful day here in Nashville, and I want to bring in my partner in crime here. It is Chris Tarr. Hey, Chris, how you doing?
There. Oh, I'm doing well. It's a beautiful day here in McGuanago at the Magnum Media Universal headquarters here in beautiful McGuanago in the 70s today. So I'm very happy about that. We're actually going to get into the 90s this week, which is the earliest that's happened in recent history. So I'm really excited about that.
And you know, just a few weeks ago, everybody was saying, oh, it's cold. It's never been this cold in April before. Oh, my God, it's global cooling.
But it was horrible. It's like, it's all over the place. You know, I don't know. I feel like there should be a tornado in my front yard because it's cold and it's hot and, you know, something is going on there. So I'm looking forward to it getting much nicer out.
Well, there have been some tornadoes, and there's been enough death and destruction out in the Midwest. So, hey, let's bring in our guest. You know, Chris, our guest is Doug Vernier, and I don't know Doug Vernier is the kind of guy that I always hear about, and I've never had any cause to work directly with Doug because I'm always like the engineer and my business partner, like Larry Fuss, or the corporate director of engineering, or somebody's dealing with Doug Vernier and not me. So I haven't had a chance to deal with him, and now I'm looking forward to talking to him directly. Do you know anything about this guy, Chris, Doug Vernier? Oh, you're muted or something, Chris. I'm still muted.
Now am I muted?
There we go. Yes.
There we go. No, he's known far and wide for Vsoft. Of course we know who he is.
Good deal. Hey, Doug, welcome in. Good to see you, sir.
Good to be here, and happy birthday, Chris.
Thank you. I don't feel a day over 75 or 80.
Hey, we are, Doug, you're going to tell us not only about Vsoft, your company, but we're going to look at some of the, not that you're giving away secrets, but we're going to try to understand some of the technologies that you use, how you put one map over another to get, okay, here's the coverage area, and here's the population in that coverage area, and things that, to me, are just kind of magical, that you can find out all kinds of information that, you need to know if you're running a business that covers ears and people. So Doug, what's your elevator pitch when you meet somebody for the first time? How do you describe what you do to people?
You want to go out tonight? You mean? No, I'm sorry.
Wrong pitch.
I describe what I do. That's difficult, actually. And my wife doesn't actually know what I do. But no, we design software, and we have the FCC using quite a bit of our stuff. And it's also used by consulting engineers throughout the U.S. And some networks and stations have it. And it will predict where the signal goes. And that's basically the way all of our software is oriented. It's designed to do FCC work, to prove the FCC that your signal is okay if you increase it, but you don't cause interference. And they're real interested about interference.
I'm going to be curious to know. I don't want the answer now, but I'm going to be curious to know about. There's probably a way the FCC is interested in understanding coverage, and then there may be other ways that station owners or engineers are interested that maybe the FCC doesn't care about, because their rules may be kind of set in concrete, set in stone, but people want to know additional things about how their station coverage. Are you going to be able to tell us some of those things?
Sure. Yeah.
Okay.
We'll do that with some of the Longley-Rice analysis that we do, and we've got some maps to show you.
Longley-Rice, that's the key word I don't understand. I'm going to look forward to an explanation. Hey, guys, real quick, I want to tell you that our friends at Nautel are a sponsor of the show, and they just got done with the Nautel Users Group. Let's hear from them real quick right now.
Scope I use all the time for AMs specifically, more than I do anything else.
Right.
But the scope, I'm finding myself using more and more in the digital realm, tracking status IOs off of remote controls that are not functioning properly. It's like so things that you can't get out, like in an open collector system where it's like, oh, is it closed or I don't know, transistor's holding it, so I'm finding myself using a digital scope more and more to do more of the data logging than I am anything else.
That is a word from the Transmission Talk Tuesday program that Nautel does. Jeff Welton from Nautel does that. They're kind of all recovering from NAB right now, so no Transmission Talk Tuesday is set up for this coming Tuesday, but there should be more in May as they get kind of reorganized, and Jeff's on a trip right now. So watch out at nautel.com/webinars and we'll try to let you know right here on This Week in Radio Tech about the next Transmission Talk Tuesday and how you can sign up to be a part of that. Really appreciate Nautel sponsoring This Week in Radio Tech, and also check out Nautel for their latest transmitter announcement, the new VX line of transmitters from Nautel. Check that out. Okay, it's This Week in Radio Tech. It's our 500 and 93rd episode. Chris Tarr's long, Doug Vernier is long, and Doug, I think we should jump right into it based on our limited time together right now. Before we get into the slides, Doug, could you answer my question about, okay, what is the FCC interested in terms of coverage? And you said interference and making sure there is none between stations versus what a station owner, a group, an engineer may want to know about. Where am I really going to cover? How can I cover this area over here with all these people and maybe not cause any interference that the FCC wouldn't like? Can you help me understand some of the techniques there?
Well, the FCC has a algorithm for doing coverage, and basically it becomes a line on the map that shows where your coverage supposedly goes, the 60 dBU typically, unless you are a Class B, and it'll be the 54. And that is exactly what they're interested in terms of how far your signal goes. And they're also interested in how strong you are over the city of license. You have to have if you're AM, a 5 millivolt over the city of license. If you're an FM, we're talking dBUs for FM. You have to have at least, if it's commercial, 70 dBU, and non-commercial is 60 dBU. Now they determine the extent of the distance that you're going to go based on the terrain, because terrain is a big factor in propagation of the RF signal. And the rougher the signal, the rougher the terrain, you would think, the more impact it has on the signal, and that's what happens. But they only look at the distance between 3.5 kilometers and 16 kilometers. And they're looking at how the terrain varies in that particular radials that go out. And they look at 8 different radials, typically the cardinal radials. Now, what happens is that if there is a hill at 17 kilometers, it never sees it. So it doesn't really tell you how far you're going to go, but it does tell you how strong your signal will be in the area that it might cause interference. So we need to do something better than that, and we go to other prediction algorithms, and there are quite a few. But the one that's long-standing and actually used by the FCC for digital television is Longley-Rice. Now, Longley-Rice is there were two engineers that came up with this, and they did some initial analysis, and they did these measurements, and the measurements determined how far the signal would go based on going further, going all the way to the receive point from the transmitter point. And that is how Longley-Rice treats terrain. It looks at the whole distance. Now, it also has some code in it for things, such sophisticated things as the size of the molecules that occupy range. And those have an impact, particularly the higher frequencies.
Mm-hmm.
And they look at a number of other factors that aren't even considered in the FM and the FCC's methodology.
Doug, if you don't mind, we've got some slides to get through, and I think they're going to give you some great examples to talk about. I'd forgotten about this Longley-Rice algorithm, so thank you for reminding me about that. But let's just jump into these here. Chris, you feel welcome to jump in too with questions, but tell us what we're looking at, Doug, with this Cape Cod Bay picture.
Yeah, well, it makes you want to go there, doesn't it? Get on the beach. This is a Longley-Rice analysis, and it's probably a little difficult to see the legend on this map, but this red area is 70 dBu and above, so that's good city signal, and it's hot, and it's very small portable radios can pick that up without any difficulty. This is FM.
Yeah.
So the green gets into the 60 to the 50 dBu. So we're going down in signal, but that you can see that it's characteristic of the land and how far the signal is from the transmitter. So you can see some of the coloring that's out there in the distance to the west, and those are additional signals, much lower. And they're all valued based on the coloration. So that's what we can do with Longley-Rice. I give you some other examples.
I'm going to guess, Doug, Chris, you probably agree. I've not been out to Cape Cod, but I'm going to guess that an overlay of household income over this map would be quite revealing and maybe a little shocking.
Yeah, I think you're right.
Probably.
All right. Can we move on, Doug? Here's another one.
This is another Longley-Rice, I believe. Let me look at this one.
Yes, it says Longley-Rice. I know it's small on your screen.
Yeah, it's very tiny. But the white contour line is the FCC line.
Oh, okay.
And the colors are the colors that you would get from the various signal levels in Longley-Rice. And so what you're looking at is a translator coverage.
Mm-hmm.
And it shows you where the signal is. And it's on a terrain backing, so you can actually see the mountains and the hills there in the background. Now, this is not necessarily at the same spot. So, I mean, this is not on Long Island or on the map that you were just looking at.
And you can see how the FCC contour in the white squiggly line, you can see how it broadly matches Longley-Rice. I mean, there's a little correlation there, but yeah, the Longley-Rice colors for coverage give you a much better indication of where your signal's actually going to go.
Right. And if you look at it carefully, some of the Longley-Rice, the 60 dBu ends very close to the FCC's contour line, 60 dBu. Mm-hmm. So it's pretty good usually. The FCC's method is pretty good, but not as good as Longley-Rice.
Let's move on to the next one here. Oh, this looks like, well, where is this? Is this in Texas? No. Where is this?
I don't know exactly where it is, but I don't think that's pertinent anyway. So
okay. It's Wyoming. I see Cheyenne in there.
Oh, okay.
Right in the middle. Cheyenne, yeah.
Sure, it's Wyoming. All right, what you're looking at here is a map of the signals. If you're doing what is called an analysis where you determine the extent of signals that you have. Now, the non-commercial stations just had, the FCC just had a window opening where you could apply for them. But part of the deal was to show that you had more first signal to a given area, and that would be first signal would be 60 dBu. Now, if it was covered by somebody else, then it wouldn't be first. It might be second, or it could be third, fourth, whatever. And so this is a map showing you the first signal area, and that is shown probably, I think, on this by the...
Looks like yellow is the first signal, first service. Yeah.
First service, there you go. And the population there, if you look carefully, you'll see what the population is. So the yellow, I think it's, what is that, 1,600 or something close to that, 1,800 people in
yeah, it says 1931 people there. Yeah.
That was a good year. So anyway, there's the a different use of our probe software on the FCC standard, but determining how many signals appear to cover a given geographic area. And you get more points if you're non-commercial, if you're not covering as much. I mean, if you're covering new people.
So if the rules, are the rules for commercial versus non-commercial stations quite different in the priorities and overlaps and things like that?
Well, they're certainly different from the standpoint that the commercial technique has some different requirements regarding short space, whether you don't meet the minimum spacings. That's Rule 73-215 in the FCC rules and regulations. If you're not meeting the minimum spacings, then you can go to this short space rule. And that doesn't apply to non-commercial unless you happen to be in the 18, like 218, which is 91.7, 91.9 area. If you're in those frequencies, you interface with the commercial band, which is anything above the first 20 channels, and the non-commercial band, and then you have to deal with a lot more when you deal with that. So there is quite a bit of difference between the rules in that respect, but they're always using the FCC method.
I'm just amazed I got a whole collection of maps here, Doug, that you've provided to me. And hey, those of you viewing or listening, hey, if you're listening to the show, I'm sorry, the maps are going to mean nothing to you. This is a show you need to watch because we do have pretty maps. This looks like the state of Iowa. Doug, what's going on here?
Well, it's an old map of the public radio stations in Iowa. The new one has many more stations, but I used to work for a public radio station, and I generated this for the board of directors of the Iowa Public Radio. In any event, it's a simple picture of the stations in Iowa based on the FCC's method. Mm-hmm. And so they become, in Iowa's pretty flat, and you can see that the circumference of these circles are very even. And the higher your antenna is, the more even your FCC's signal going to be. But if you put it low, you're going to hit that terrain. And these things are going to vary. They're going to waver in those lines. So you can see that at the time we did this, Iowa Public Radio had just the three institutions, the university institutions, and merged. And so the stations in the pink are the original stations.
That brings me to a question before we take our first commercial break here. And Chris, maybe you got some experience with this. You know, you mentioned, Doug, that there's all kinds of things that can hurt your signal in a given azimuth, in a given direction. A hill would be pretty obvious. Sometimes a great big building, or terrain that rose and then fell away lower, you wouldn't cover, maybe not a hill per se, but a very broad plateau. You may not cover behind the plateau. Is there any condition, naturally occurring condition, that will throw your signal a little farther?
More power.
More power, okay, or more height, yeah.
Well, height obviously it gives you better profile.
Yeah,
But
you can also kind of play the game with height above average terrain based on how the FCC measured, how many radials you have that are above or below, and you can kind of work that a little bit if you really wanted to be strategic. But
that is correct, Chris. In fact, it's typically that you would use 8 radials, but if you play around with it, maybe as long as they're even, you can do an even amount. You can do 36, you can do 72, you can do 360, and then average them all up. And there are occasions when it makes a difference in what class you can fall into, because the class of a station, whether it's A or a class B, falls into, well, there's a zone with the Bs and the As, but As or Cs, let me use that. It is depends on the height above average terrain. That's exactly what sets your class. So,
right, and sometimes you can use that and Longley-Rice to your advantage a little bit. A great example that we just used was I'm moving a station, a Class A, from north of Madison, Wisconsin to south, and the original site that we were going to build this new FM at became unavailable. And it turns out that in the process, in the time that it's taken, we bought another group of stations nearby, and we have a tower that we can put it on. However, the 70 dBu was not fully covering 50% of the city of license. However, based on the terrain and the Longley-Rice, we added that. And although the FCC doesn't take that, they will consider it.
yes, that's
And so we put that along with the packet to show that, well, based on Longley-Rice, we absolutely cover the entire city of license and then some, based on terrain and some other factors. So yeah, I mean, there are times when you can really, obviously, there are limits to the laws of physics and to what the FCC will ultimately allow, but there are some tweaks and things that you can really do to optimize things for sure.
That's why you hire a good engineer, consulting engineer, because they know all the tricks of the trade, and they'll get you the most power you're going to get possible.
Yeah, that is, the guy I use is great, and I tell you what, you find somebody like that, and they're worth their weight in gold for sure.
That's for sure.
We're talking to Doug Vernier. Chris Tarr is along here, and we're talking to Doug Vernier. Doug is founder of Vsoft, and we'll put links to that in the show notes and have Doug tell us a little bit about that toward the end of the show. We're going to take a quick break here and be right back. When I was at the NAB show just a week ago, I visited with the folks at Broadcast Bionics and got a real great demonstration of something that, well, if you're a fan of this show, you've seen before, and that is their Camera One system. It's really cool.
Camera One from Broadcast Bionics, designed to bring video to your audio content, visualizing radio and podcasts for social media. Camera One can automatically create, capture and brand professionally switched video for live streaming or upload, making your production shareable. Control and configure using a web browser on any device. Camera One is available as a 4-camera or 8-camera system using the Blackmagic A10 Mini range, including the A10 Mini Extreme. You can use cameras to suit your studio and your budget. You'll need one camera for a studio wide shot and usually one camera per microphone. A standard multi-channel sound card or IP driver monitors audio from each studio microphone, and we work natively with Axia systems. Ideally, this will be a post-fader feed from each mic, although you can use pre-fade audio or a mic split if that's all you have available. These audio levels are used to intelligently switch the video feed when each contributor is talking. You can also group microphones together into one shot and use the audio from a mixer's aux bus. You can use Camera One's auto switch feature, or disable it and switch using the on-screen buttons or the buttons on the A10. Recordings can automatically start when you tell the system you're on the air. This on-air indication can be linked to your studio's red lights via IP or an Avantec Adam GPIO interface. You can quickly browse all the videos that have been automatically created during your broadcast, download them and post. Camera One is a user-installable system. You'll need a good spec Windows 10 PC, i7 with plenty of storage and 16 gig of RAM. It's better if this machine isn't used for anything else. Remember, you can control the software in a web browser on another device on your network. Camera One, a thrifty way of creating scroll-stopping video from your show or podcast from Broadcast Bionics.
Thanks a lot to Broadcast Bionics, and check them out at bionic.radio. That's their web address, bionic.radio. All right, it is Kirk Harnack along with Chris Tarr, and Doug Vernier is our guest. You've probably heard his name before or heard of his software, vSoft, that does, and he has other software products too. We're going to get Doug to talk about that before the end of the show. In the meantime, I think we're going to continue on with looking at maps that are the product of Doug's different software solutions. So, Doug, if you don't mind, can we jump right back into them?
Sure.
We've been through 4 slides. We got about 11 to go. This looks weird. What am I looking at here?
Well, this is a non-commercial study for a station determining how it might interfere with Channel 6 TV.
Oh.
The Channel 6 full-service TV stations are fully protected by everything, by translators and by full-service non-commercial stations that are coming on the air as new, or whether you move, it happens to move, when you might move your transmitter, then you have to prove again that you're not causing more interference than you were in the previous location. You have to do it in this method, which is a U to D method, which means undesired to desired. So what we do is we look at the signal coming from the TV station, and there's a set of rules that shows you how much signal you can have as an FM based on how close your frequency is to channel 6, which is right down on the low end of the non-commercial band, just below that is where it sits. And so the stations that are transmitting on frequencies that are closer to the non-commercial band are more curtailed in what they can transmit. And the way they do it is that you can have 3,000 people in the interference area. Now, this U to D study indicates that that purplish area is all the interference area, and it's based on where the U to D, the undesired to the desired. Now, the undesired is coming in from the non-commercial station, and the desired, of course, is your Channel 6 TV station. So this shows you some of the, I don't know if you can see it real carefully, but there's actually the pixels of where the population or the people are located based on the U.S. Census. And that's how the program will automatically count the census in that interference area. So you don't have to go count those individual census points by counting them physically.
So I noticed from the legend here that the Channel 6 is considered on 85 megahertz, and the FM station is at 91.3, and so the pink is the potential interference area between those two, correct?
Right, yes. And if it was 91 or 81, let's see, 89.3, move it down in the band, this would expand. You'd see a much larger U to D indication here.
Now, with this level of interference, is this an amount that the Channel 6 owners would say, no, we object, you can't do that, you're going to hurt our viewership?
Well, this was less than 3,000 people.
Yeah, yes, 1,930 according to your calculation.
And so as we go with this procedure, we reduce the power or put in a directional antenna, and we can actually work. There's another way you can do it. It gets a little complicated, but you have horizontal and vertical polarization from the TV station, from the FM station. And it's the vertical polarization that is okay. The horizontal polarization is the same way most TV stations transmit, although they're not all doing that anymore. But that was during the time when these rules were set up. By the way, the FCC set them up for analog TV, and of course now we're way past that with digital TV, and they haven't changed a bit any of the procedure. So
I don't know if Chris has run across this or not. Years ago, I built a new non-commercial religious FM that we had to go with a vertical only antenna. It was several bays of vertical only, and I wasn't involved, with the allocation, as Doug, you may have been, or another consulting engineer was. But yeah, we had a good time ordering a vertical only antenna and putting that thing up.
Well, and there's some other ways too. In larger cities, a lot of times what they'll do is they'll co-locate the educational FMs on the Channel 6 TV tower.
Yes.
One of the bigger issues is that the analog audio on Channel 6 is 87.75. So that's where some of that interference comes into play as well. Now, of course, that isn't much of an issue anymore. But as Doug said, they still have the rules, which is, a little bit crazy, but also very typical of the FCC. With they tend to hang on to those rules long past their kind of expiration date for when we need them.
Doug, Chris mentioned something that maybe you can just make real clear for me. Chris mentioned that you could co-locate if the FM and the TV could co-locate their transmitting antennas. This kind of solves the problem because why?
Well, it's like dropping a pebble in the lake. You can, if you drop the pebble in, you can see the waves going out. If you drop a pebble in right next to it, the waves are still going out pretty closely. I mean, they're not affected. But if you drop it within, let's say, a foot, then those patterns come together and cause interference. And so that's one of the reasons why it seems to be helpful to go co-locate.
Those signals will always be. Let's assume the TV is more powerful and the FM's down here, but that they'll decrease together as they travel away from the transmitter side. You'll have the same ratio all the time.
Yes, well, that depends on how well the coordination is of the vertical elevation field of the antennas. That's the vertical field where the antenna is coming down. If you have a multi-bay antenna, that's going to waver up and down. If you happen to be wavering in a given location or a given distance that's coming down from the tower, and there's a TV station there, you could actually, or a TV receiver, you could actually cause interference with that. And that's why part of the rules require matching the vertical elevation field of each one.
I believe, Chris Tarr, you said you're going to have to go pretty soon. Were there any questions specifically? Because, now I don't know if Doug's on the clock right now or not, but you might be able to ask him a question before you have to go.
Like I say, like Doug, I know many really good consulting engineers. I am just a big fan of the software. I'm in the process of talking the guy I work for into buying the FM Commander. But I what an amazing, it must feel pretty good to you to know that the FCC actually takes your software as almost like gold. When people do these filings, they'll say that, we've used Vsoft to do this search and to do this and that. And the FCC takes that as something of basically of value, that, okay, well, if it's coming from that, then we know that the data is good. That's got to make you feel good. I mean, that's a pretty big accomplishment.
It does. And all of the AM engineers use our software. The FM engineers use a combination of their own software, and they will use our software to do some checking at times, particularly if it's real close. They want to see it in our software as well. And some of the things we can do with our software that they're not very good at because of their software is determining the percentage of populations, because they have to keep up with the city of license has a boundary. And it has to be, like Chris was saying earlier, you have to cover 50%. The non-commercial stations have to cover 50% of the city of license boundary. So they use our software for that purpose, and the OET uses it as well. Also, Industry Canada is using it for just about all of their work on AM right now.
Chris, I want to respect your time, so let me know if you got to go now or you want to hang on a few minutes.
I like Chris's questions. He's got
Oh.
good questions. I want to see him though.
Well, I appreciate that. No, I do have to run here in a minute, so I'll duck out. But yeah, it's been great to have you on, especially again, been a big fan of the software for a long time. One of the things I do a lot of is I'm a big fan of. I'm a geek, big fan of FCC rulings and those sorts of things. So I scour the database. So, I've seen a lot of the work that's come out of Vsoft in terms of the final products. And, there are examples, and I've used them a couple of times, where that software has really been able to, as an engineer, to be able to make some changes that normally wouldn't be able to be made just based on the FCC contours. So I do, it's amazing to me, and amazing yet not surprising, that the FCC is still stuck in this kind of old way of doing things with the contours, because that's just a circle on a piece of paper. And we all know that, as this stuff gets out into the air, it doesn't perform like that. The signal doesn't know that the signal doesn't know where the boundaries of that circle is. So even in just what if scenarios, to be able to plot that out and say, well, if we make this change, even the height of the tower, or where the antenna is on the tower, or any of those things, to be able to see in reality what that's going to change that's a significant thing. And then, as you said, with population coverage changes and things like that, it really, for us to do the best job we can for the people that we do work for, we have to have that information. We have to be able to look at that, other than just taking a compass and drawing a circle on a piece of paper. We're not doing anybody any good if we don't do that. So yeah, I just again, it's just been great to hear some of this stuff and see some of the maps that have come out of it.
Chris, you'll have to watch the replay to see the rest of the maps, as we got about 9 or 10 maps to go.
Well, thanks for the comments and the compliment, Chris. Very nice of you.
You're welcome. All right, I'm going to duck out.
Okay, Chris.
See you in a bit.
See you. Take care. All right, Doug, we're going to run back into the maps here. My goodness, this looks complicated. Where is this? I'm not sure. Somewhere Lancaster, Whitefield.
Well, Lancaster would be Pennsylvania.
Little John, in North Conway. All right.
I don't know where that is, actually.
This is then there's
Longley-Rice. And we call this one just a standard Longley-Rice. And you see how the FCC contours, basically the Longley-Rice sort of fits right in with the FCC, although a lot of that green in the lower right corner there comes, it's very high signal, but the methodology of the FCC with the contour line doesn't even see that. And they don't care about that. In fact, they only protect other stations to the 60 dBu if they're Class A's or C's.
Right.
And not anything more than that. And so a lot of managers will say, take a Longley-Rice and say, well, I got signal out here, and it's way past my 60 dBu, and people are sitting there listening. But what they didn't take into consideration was the interference. And because you're not protected all over there. And we have one of the Longley-Rice maps we do is the interference free. So we actually take all the other stations that might be causing interference and calculate in the impact of their transmissions and give you a much better idea of what the whole signal coverage is.
Okay, so this makes perfect sense. So just because you put signal somewhere doesn't mean that you're going to be able to hear it there due to interference from another station on the same frequency or an adjacent channel. So the interference-free Longley-Rice sounds really interesting. You could probably use that in your sales department. Hey, go hit this area. We cover there, and we're not interfered with there.
Yes, that's right. That's a good example. Mm-hmm.
All right, let's move on here. Where are we here? I can't read these tiny town names. Oh, it looks like California with the bay there on the left. Yeah.
That's San Francisco to the left.
Yeah, so we're inland here. Inland.
You can see, one of the things you can see there is where the terrain drops down. There's rivers and where there's lakes, and you see that the signal actually drops out or drops way down, and to a certain extent might drop out if you have a radio there. Also, you can see that in a rugged terrain area, your signal is anything but uniform. It just has juts out in different directions, and it's not a circle anymore.
You can see that this signal, and this is between Sacramento and Stockton, California. I guess that's the Inland Empire area. Is that what you'd call that? Where it's almost like a bit of a bowl there. The signal's certainly constrained by the terrain on the lower left and then the rising terrain on the upper right.
That's correct. That's what you're seeing.
Wow. Okay. All right. Here we are in beautiful Las Vegas, right? Yeah.
Yeah. This is a shadow map.
Oh.
And of course, FM is basically NTV because of the frequencies. It's basically line of sight. And this shows you from that tower and that antenna where the shadows begin. And you can see those are the darker areas of the map. So that's not a real signal algorithm, but it is a geographic map of the shadows that appear when your antenna meets those other points on a direct line.
Sure. Okay. All right. Here we are near Lake Michigan. So
right. This is a different algorithm. This is using Okamura, which is an algorithm that the Japanese came up with, and it's been modified by Cost and Hada and a bunch of other propagation experts over the years. And I believe this is just a standard Okamura without cost involved. COST is a person's name. And it you can see when it hits the ocean there.
Or the Lake Michigan, yeah.
Yeah, or the Lake Michigan, it just juts way out. And a lot of times our software will have a switch and just won't put that in because there's nobody out there.
Yeah, this says it's for 800 megahertz with a pretty high antenna, 539 meters, but the average receive height is just 1.5 meters above ground.
This would be the typical police radio, ambulance radio, and the Okamura is a good terrain, or rather a good algorithm for built-up areas for cities. And it does not use terrain at all.
Okay.
It uses the signal strength and a few other, depending on the antenna height, it uses some other factors.
Well, that is Chicago, so it certainly is built up, and that's. I'm surprised that there's that the half of the circle on the left side, the pink or magenta there. I'm surprised it's as regular as it is.
Yes, well, that's because it's a high antenna.
Ah, okay. Gotcha. Well, moving on in interest of time, Denver, Colorado. What is this?
Well, we're looking at another propagation algorithm. This is the Ptp algorithm. This algorithm was made known by an FCC engineer, OET engineer, the Office of Engineering Technology. And it is an interesting algorithm. It's very much like Longley-Rice. It uses a lot of those techniques. And the problem that you have with it, basically it's an algorithm designed for contours. And when you run out radial in a given direction, you have a lot of different terrain. Well, it will actually, if you're looking for the 60 dBu, you'll find that it goes below 60 dBu, and then it rises back up.
Oh. Mm-hmm.
That's because of the terrain. You got a hill up where it rises. So the question is, if you're using just a contour like that, where do you cut it off, and where does that become an actual value? And that's the problem they had with making this thing work at the FCC for regular managing of applications that come in. So they never did adopt it fully. They had it in the rules, but they didn't adopt it. So, but we have it and we can use it. It's part of the algorithm.
I'm glad you pointed out that PTP v2 is a type of analysis for coverage because it's also, in the IT world, it stands for Precision Time Protocol, and they're up to version 2. So it's...
Is that right?
Yeah, we have one name, two very different things. But look at that. This is KVOD, 50 kilowatts at 90.1, and they cover an enormous area. Even up into Cheyenne, Wyoming, just about. So if you're driving on, Interstate 25 from Denver to the north of Cheyenne, you're going to be able to carry this station nearly all the way with probably just a few dropouts.
Well, that's a good point. We're not looking at the interference-free.
Okay.
So that's going to be a little different. But this is where there's actually RF out there, but whether there's interference is another question.
If we could get everybody to go off the air, then that would be the coverage, wouldn't it?
Yeah.
Wow. All right. Hey, it's Kirk Harnack and Doug Vernier. We are talking about coverage maps and the different things that Doug's software can do to help you look at your coverage map. We are up against another quick break here. Doug and I will be right back after I tell you a little bit about my friend Hank at Henry Engineering, Hank Landsberg. This is the Henry Superlight. We've been talking about this for years until we get it drilled into your head and you order some for your radio station or wherever you need to have a tally light that runs an LED light. LEDs are certainly the way that we've been putting in tally lights, on-air lights for some time now, and even the lights that, may attach or be part of your mic stand. This can really help you get it done. The Henry Superlight is an LED tally light controller. And let's see if I can click the right button here and maybe make this thing work. There we go. There's the web page for the Henry Superlight. It has a couple of what look like RJ45 connections on it, and that's just used for wiring convenience. There's no IP address or IP intelligence here. That's just used because it's a convenient connector to let you hook several of these together. There's some jumpers inside. You can take the top off. You got 4 little screws and set the jumpers inside to let you have up to 4 of them that are just daisy chained together. 1, 2, 3, 4. And you can go from let's say you have a wiring area, you have a central rack area. You can easily wire up 4 of these in series or not. I mean, it's up to you. I'm just saying you can do this to make it easier for you to wire them together and to wire your on-air lights from whatever kind of GPIO, in this case GPO, that you would be having from your typically audio over IP audio equipment. You're going to have some GPIOs available, and you can wire these to the Henry Superlight. They will supply you with 12-volt DC at up to half an amp to run your LEDs, or you can use an external power supply and get a bit more power out of that. I think up to an amp or so coming out of this. It also gives you some extra relay outputs. It's got 2 normally opened outputs and 2 normally closed outputs, and you can use these to mute a ringer on a phone if you need to. You could even mute some speakers if you needed to do that, if your system doesn't do that for you, or if it's just more convenient to use the Henry Superlight to do it. The Henry Superlight is just one of many, many, many products that Hank Landsberg at Henry Engineering makes to help you build studios, radio, TV, podcast studios, home studios. You can really get a lot of utility out of the things that Henry Engineering makes. And of course, where do you get this? You get it at Broadcasters General Store. There's the website for BGS. The website is bgs.cc, bgs.cc. Or you can do what I do and give them a call. Call Broadcast General Store at 352-622-7700. 352-622-7700. They have lots of things for you to build pro video studios, pro audio. They have RF equipment as well, racks and cases. I get all my racks, rack shelves, that kind of stuff from Broadcasters General Store. So check them out if you will. I love them, and I think you will as well. Thanks a lot, Broadcasters General Store, for sponsoring This Week in Radio Tech. Really appreciate it. Thanks a lot to Hank Landsberg and the Henry Superlight and all the Henry Engineering Products that he's got. Okay, it's Kirk Harnack in the Telos Alliance studio talking with Doug Vernier. Let's bring Doug back. There we go, Doug. And let's see, Doug, if I can find the next slide. This one looks interesting. I'm just thinking a little tiny thumbnail, but this one looks like some kind of a rainbow donut going on here. Let me bring this map up. There we go. This is southwest of Chicago. What do we see here?
Well, you're looking at FCC contours. They are shown on the circumference of the semicircles. And that's Longley-Rice in the middle there. Now, what this means is that these are typically FCC contours, but there are stations causing interference out there. And what we're showing is the interference areas. So the green and the purple and looks like gray are interfering signals coming in from other stations, reducing your real life coverage because of those interference. And that interference is based on the FCC's U to D for the channel relationship. If it's co-channel, then the interfering signal has got to be at least 20 dB below the signal that is your prime signal that you want to keep interference40 And so if it's first adjacent, it only needs to be 6 dB below. And then if you go to second and third adjacent, it's 40 dB above.
Oh, yeah.
You're going to have one heck of a strong signal without causing interference for second and third adjacencies.
This map, this study you did, just happens to be close to Chris Tarr's old stomping ground. In fact, I first met Chris in Joliet, Illinois. So it's very, very close by. We met on the September 11th. How about that?
Oh, boy.
Wow. Hey, next map, and I'm sorry, we got about 4 to go before we end the show, and I want to find out this is Lansing, Michigan. What's going on here?
Right. Well, this is along the Rice where we have actually subtracted. So this is an interference-free Longley-Rice, and it shows you what the signal is based on interference-free area, and that's any area that you see there in this particular map. The blue and the orange and the green are areas where your signal is received, but the white areas there are where you thought you might be, but you're not because of interference.
You know, this map, I saw it, Doug, and I thought, looks like Cookie Monster's been here. taking bites out of it. The white areas would have had coverage if not for the interfering station, legal interference. I mean, it's just the next station either on the co-channel or adjacent channel, right?
That's right. But if you look at the inner circle, and you look at the contour line, that's 60 dBu. So basically, you're okay with the 60 dBu. But there are some places where a little of your 60 dBu, which is supposed to be always protected, are not quite protected, like to the west there. It looks like there's an indent.
Well, I see the 54 dBu line, and then it looks like there's a 60 that's hard to see because it's a black line mostly over the dark blue area. But at the bottom there, south of Lansing, it does pop out of the dark blue a little bit. I guess that's the 60 dBu.
The 60 dBu is the one that's close to the blue and the green.
Yeah. Oh, yeah. I see that. I see the legend there, up near, right under 54 dBu near the top there. It says 60 dBu.
Right.
So this is the kind of map you're talking about where it's Longley-Rice, so it's pretty realistic, but with the interference areas removed.
That's correct.
From the coverage. Wow. Okay. That looks like it'd be very helpful, for sales efforts. You could go out and sell don't sell in the white areas. Ain't gonna work.
Well, some stations don't want to show you that. They just want to show you the 54 FCC contour line.
Sure. Yeah. Good point. Oh, this is interesting. This looks like Manhattan Island in New York.
Yes. And what you're looking at here is an interference area determined by U to D, Longley-Rice. And you can see this is a this is a booster that came in that's causing all of this interference. If the actual interference is the red in this area where the booster is, and the signal that's coming in from the west is a public radio station, and they had signal in on Manhattan, Upper Manhattan, and they lost it because of this booster, which is it causes interference to their signal. And I think that's the 60 dBu or the 54 dBu. I'm not sure which one that line is, but the boosters are legal and typically can cause that kind of interference, but they have to be on the same channel. And of course, then you have issues of interference with yourself.
Yeah, yeah. So all the people in the red areas are not able to properly receive the public station of interest, right?
That is correct, where they had signal before.
And wow. And so was this proving something illegal, or was this showing, is this perfectly legal?
As I recall, there was a petition to deny.
Ah, okay. Okay.
The petition to deny was denied because it met the rules.
Oh, even though it caused that reception interference, it still met the rules.
The booster is on your channel.
Yeah.
And it's your space. And if you want to put another signal in it that's your own, that's fine. And if it happens to interfere with somebody else that happens to be okay before you go in there, that's too bad.
Yeah. Wow. Wow. And the boosters, I take it in this case, looks like it doesn't increase the coverage of the station that it's boosting, but what is this? Is this kind of like some blanketing interference that it would provide?
Well, the booster is increasing the coverage in the populated area of Manhattan where you have all these, big buildings.
Right.
It's like subterranean tunnels that you have to get through. So a booster gives you better penetration into those buildings.
Gotcha. 2 slides to go here, and then so this is another one from the New York area. Here we are on Long Island.
Right. What is this one? To figure that one out.
It's the Longley-Rice coverage for a VHF repeater.
Oh, okay.
At 145.21.
This is a ham repeater, and because I'm a ham radio operator, this was done for a club, and I was happy to do it. This was a volunteer freebie. But anyway, it shows you the VHF signal and a very higher, it's high frequency there.
Yeah.
And and you can see where when it goes out over the lake, it gets round because there's nothing to block it. There's no terrain.
Sure. What would the gray area be like? Just outside the magenta area? What would that gray area coverage be like?
That would be the secondary signal, and I think that was a 54 dBu out there. Or, well, not the 54, but
I think the legend is saying 0.0 to 0.1, but I can't see the units.
The units would be millivolts per meter.
Millivolts, okay.
Yeah. And I really can't see it from here.
Gotcha. Well, 0.1 millivolts is pretty small, but if you're a narrow bandwidth, you might be okay.
Well, that's good signal for ham radio repeaters. They go down to the 0.1.
Ah, yeah. That's a good deal. All right, we have a last slide here. We're back in Iowa, back in your stomping grounds, huh?
That's correct. This is, I think it's WOI. This is their signal, AM. And what we've done, typically you don't make a map of various colorations, but our software, our AM software, can do that, and it kind of gives you an idea of where the secondary signal would be on AM. AM, of course, as you well know, is very difficult as a medium, as a band, because of all of the fluorescent lights and interference that is caused to the AM band. And the FCC is aware of that and looking at receivers, but they're not there yet.
Gotcha. Yeah, I'd heard about that. Boy, Doug, we've taken a look at 15 different slides, different pictures, different kinds of maps. What a variety. We're going to come back to you at the end of the show here after this last announcement to find out more about some of the highlights of the software that you do, what it can do for you. And, of course, we'll have links in the show notes to the various pages. Right now, for just a minute, Doug, I'm going to chat about a couple of our sponsors, one of them being the folks at Angry Audio, now owners of Studio Hub. And this is a new, I'm going to hold it here so you can see it all. This is the new world panel from Studio Hub. That means you can put this in your studio and give people access, like a TV station comes in, they want to get your program audio to record along with the news story that they're doing, or somebody brings in a device that maybe they bring in a CD player. You don't have a CD player in your studio because you play everything off your automation system. You can plug things in, take things out. This will handle analog in and out, plus AES EBU in and out if you have that. And you can even, if you have it's got some things here that are just connections through, no electronics, like a USB connection. You can bring that through if you like. And even a place for your LAN connection right there. That's the RJ45 jack, or maybe it's for your AOIP network. Anyway, there's plenty you can do. And this is actually an active device. It's not just a passive world panel. It's an active world panel. And that means that if somebody plugs something stupid into one of these connectors, you're protected here because this has active electronics in it that will take the brunt, and not your audio console, right? Will take the brunt of what you're doing. So this thing is just awesome. It's so beautiful. And in fact, I need to bring this up and show you a little testimonial. Here we go. Let me see if I can click and bring this page up for you. There we go. This is the web page from Angry Audio. This is their Studio Hub page, and that's it. That's the world panel. And there is, if you want to go to that web page at your leisure, I'll put a link to it in the show notes. This is my friend Marcus O'Rourke out at K-Wave in the Los Angeles area, and he's been using these world panels at K-Wave. Marcus is just one heck of a good engineer and always does things that really serve the convenience needs of the people who work there. So check this thing out. There's all the gazintas and gazoutas and the information on it. That is the world panel from Studio Hub. Let's see if I can get me back on. There we go. And Angry Audio. AngryAudio.com is the website you want to go to. AngryAudio.com. Thanks a lot for sponsoring This Week in Radio Tech. We also are sponsored by our friends at Max Connect Wireless. Here's John Takak to tell you a little bit more about why Max Connect is something that you should be doing.
With all of the recent cybersecurity attacks against large corporations, we were looking for a product that would give us the ultimate security at our transmitter sites and as well as with our broadcast equipment. Max Connect fits the bill very well. Its greatest security feature is the fact that it gives you a single static IP address. Using this single static IP address allows us to close hundreds of open ports on our firewalls across the company and restrict access to only the Max Connect IPs. This has greatly reduced our exposure to the World Wide Web and made us much more secure moving forward. It has also given us the ability to expand as needed in a secure fashion.
Talking about Max Connect Wireless. You can get Max Connect Wireless modems in several different formats. Here's a Cradle Point, here's a PEP Wave, but it's really not the modem that makes the difference. It's the SIM card inside that Josh Bone and his company Max Connect Wireless have put together that gives you that prioritized data, prioritizing it over everybody else except for first responders, and the fixed IP address. You want to check out their website? Well, you can do so. It's at maxconnect.com, or you can add the word wireless. That'll work too. It's spelled funny. So it's a link in the show notes. And whether you like AT&T, T-Mobile, or Verizon, they have deals with all these companies that you can get prioritized data that way. There's a little testimonial from me and a little advertisement. And then here's just a graphic just pointing out that you can put a Max Connect LTE router at your transmitter site, for example, and connect many devices to it that need to use the data. You can use this on broadcast remotes, transmitter sites. Hey, emergency internet for your radio station. I certainly have used it for that before because I really needed it one time when we didn't have any internet at our stations. Check it out. Thanks a lot, Josh Bone, for Max Connect Wireless. All right, we're in our final couple of minutes here with Doug Vernier. And Doug, let me put you on here, and I'll actually put us both on. And I'll need to bring up your website. I didn't have it. Actually, I have it ready on a different computer, but let me bring up vsoft.com and tell us a little bit about. I see lots of different products here. Let me hit the products button. FM Commander is something that Chris Tarr talked about. What is FM Commander?
Well, FM Commander is our FM specialty program, and it deals with finding frequencies for FM, commercial, non-commercial, low power FM, and translators and boosters. It will do everything you need to do. It knows the rules, and it helps you as you go along. It has maps integrated with it. You can see what your coverage is based on the FCC's methodology. And it has printouts that you can send to the FCC with your application that has the terrain, shows what is happening with the terrain. And they're called FM overs, which is a name the FCC has given their software that does the same thing. And so you're just seeing some examples there on that front page of FM Commander's maps. And like I say, it's particularly designed to help you. And it has all kinds of pop-ups that says, you're a Class A, but your power is beyond the 6 kilowatt Class A. Or if your antenna height is too high and your power is okay, it'll tell you that you have to reduce your antenna height because your 1 millivolt goes out more for a Class A than 28 kilometers, which is the maximum.
I'm kind of interested in plot path. I haven't seen it yet, so this is my first look. Oh, it's kind of what I expected. Plot path.
Yeah, that's for microwave or for standard paths, radio paths. It can be your ENG path, and it uses the terrain. And we have terrain that actually goes down every 30 seconds or 30 is it 30 meters? Yeah, 30 meters. There's another point. And so it gives you a good idea of your signal. And it will tell you what your signal is up there in the hill when you're sending it up.
And it looks like you're taking care of Fresnel zone calculation as well with that yellow line.
Yes. It's a little hard to see, but that yellow is the Fresnel. And of course, if you extend terrain into it, it will cause the deterioration or attenuation of the signal.
What's I've shown FM Commander and Plot Path. What's your next favorite product?
Well, we have, of course, the probe. A lot of the Longley-Rice that you've seen is the probe.
Oh, yeah.
Probe 5. Yes. And we, a little bit about that, but there's so much more than what we've talked about in there. That's actually a 7.5 minute background. And we have those for the whole country. You can use those if you like. So that's one of my favorites. And of course, the AM Pro, we haven't talked much about that one, but that's the one that is used every day by engineers at the FCC. Mm-hmm. Apparently they like it enough to use it as the bell weather for all of AM that they work on. And then we have a program that's designed for translators.
Oh, what's that called?
It's called Xfield. And, translators, you probably know that they can operate in the channel, the spaces between the stations.
Uh-huh.
So you can be second adjacent from a full service station and operate. The FCC will let you do that, but you can't cause interference over that spot. And it all depends, again, on the vertical elevation field that you're generating. And Xfield will actually take that into consideration in your pattern. And it will draw how high your interfering signal is off the ground. If there's buildings there, or if there's highways, people, you can't use that site. You have to use a different site.
Okay, I got to ask a question, Doug. How smart do you have to be to use your software?
I don't know if that's a definition answer I can give you. It depends. We have all kinds of people. I'll tell you, people call me and I do my best. And a lot of it is just learning it and one step at a time and going on. We have very good manuals and online help, and we have videos on YouTube. So all of those are designed to help you out.
I'm guessing that for someone who's not an FCC consulting engineer, and you may hire a consulting engineer to use the software for you or to make the application that, not exactly a lay person, but someone like me with a certain amount of knowledge could use this software to kind of narrow down what I want to do or see if it's going to work, and then call my consulting engineer and say, hey, I think this is going to work if I do this and do this. Is that how it's used quite a bit?
Absolutely, you can. And you can send them what we call the job file that you use to create that, and they can run it on their computer. So yes, it certainly can be done. A lot of people do what ifs,
Yeah.
And they don't have to hire an engineer.
I like the what ifs, like, what if my transmitter was on the International Space Station? How would my coverage look then?
Yeah. It would be okay.
Doug, we got to go. You've been delightful to chat with, and I'm so glad that we've gotten to know each other for the last hour and 10 minutes or so on the show here. It's been great. I'm glad that Chris was able to join us for the first half of the show. If people want to find your software, I guess it's at v-soft.com. Is that right?
That's correct. And it is a dash or a hyphen.
Yeah, v-soft.com. Hang on a minute. We'll say our proper goodbyes in just a minute. Thanks a lot for joining us here on This Week in Radio Tech. Doug Vernier has been our guest on TWiRT, and Chris Tarr was with us for a while. I'm Kirk Harnack. Thanks a lot to the fellow who normally produces the show. He added some nice graphics on this one, and that is Suncast. Thanks also to Andrew Zarian, the founder of the GFQ Network. We'll see you next week on This Week in Radio Tech. Bye-bye.